Okay, short introduction to asynchronous programming. Please forgive any spelling mistakes. I did not check this. Okay, so for those of you who are unaware by what I mean by asynchronous programming, usually when you write code and when you execute code, it will be done in a linear fashion. It will be done line by line. Line 1 is fired, and then once that is resolved, line 2 is fired. If you have a function in there, the entire function has to resolve, and then after it has returned its value or returned anything, the next line of code is run. Asynchronous programming introduces the concept of being able to run code in parallel. You can call an asynchronous function and then not have to wait for it to fully resolve before continuing on with the current thread. This is used probably most usually in any sort of networking application, any sort of heavy computation that needs to run while the user does something else. Graphics has a lot of multi-threading applications in physics. So in a lot of modern video games, there's going to be a lot of threads there all running in parallel to get the most out of the hardware. So it's a very, very broad term, and there's a lot of different things that fall under the category of air quotes asynchronous. So I would expect that there's a lot of industries that would use these concepts. So examples in the web, as I have said, Enigma Interactive is a digital web agency. We make websites, and the forefront of making websites is we need to make a website that the user likes to use, and is quick, is responsive, gives the right data and the right information, and well, there's a lot of requirements for making a good website. So, for instance, you want it to load fast. Generally, how you go about this is, or a good way of doing it is, load parts of the website at once. So, let's say if you go onto your main Facebook feed and it has that infinite scroll in the middle, you're not going to load all of the infinite scroll. When you get down to the bottom of the page, it loads in more stuff. That's an asynchronous call, because when you get to the bottom, it sends a request over to the server, and then while that request is getting back, you can still do other things. You can scroll back up, or you can click on something else and ignore the initial call and go do whatever. Or when you first load in the web page, the first thing that loads is the text and the styling and the stuff around the content, because that's very quick to load. That actually requires very little data to be transferred to build that website structure. Images, on the other hand, are quite big for file sizes, so they take longer to fetch from the server. You want to do that asynchronously. You want to load the quick stuff first and then deal with the fancy images. That's called lazy loading, for anybody who wanted the industry term for that. And then likewise, if you're using a mobile application and you want to fetch something from memory, like if you want to load an image, generally that is done with asynchronous calls, because you want feedback. If you click load an image, you want something to happen to confirm that you've made that request. You don't necessarily want the image instantaneously. You're okay with waiting for a second while it loads, but you want that initial feedback. So the device needs to be able to do a couple of things at the same time. And that's where asynchronous programming comes in, is you can request the big thing, but then deal with the user in small ways while they wait. And in general terms, it's whenever you want something that's going to take a long time. Again, it's a long time in terms of computers, and you don't want the user to be looking at a blank screen for any length of time, really. asynchronous programming is a really good way of dealing with that problem. And to show off some of the principles, I've got a few code snippets here. So anyone who doesn't care about code, you can leave at this point, because it's just going to be the technical stuff at this point onwards. But I think this is probably the best way of just demonstrating the actual applications of this. So I've got a very simple function here of what you would expect. So this is written in TypeScript, which is basically JavaScript with some extra bits and pieces on top. And if you go through it line by line, we're defining a function, we define data, which is just some variable, and then we send a GET request to an example website. The asynchronous part comes in with the GET request and toPromise. So a promise is how JavaScript does its asynchronous stuff. So a promise is you make a function call, it returns a promise, and the promise resolves whenever you get the data back. And we can set up a definition of what happens after the promise has resolved, and that's where the .then function comes in. So we can pass in another function which defines what we do with the response. So once we've got the response from example site, we simply say, okay, store that response in the data variable. We also have to make sure that if that promise encounters an error, so if the website's unreachable, if the website encounters an error and then returns an error message, or it times out, we have some error handling. Not actually implemented here, it simply catches the error and then it fails silently, but you can put any sort of error catching in there that you want. And then afterwards, we can pass that data to another function. And that other function will presumably do something to the data that we want to do with it. So I've written it out like this to illustrate a problem that often occurs when you're dealing with asynchronous code. And so this code would probably fail. It would not work as intended. And that's because although the promise and the GET request and all that biz is asynchronous, the call to another function isn't. That's synchronous code. That happens in the usual execution of synchronous programming. So what would likely happen here is that you'd get to another function before the promise has resolved, meaning that data hasn't actually been populated with any data. You'd end up passing a null object. This is bad. Don't do this. It's a very common pitfall, especially when you're starting out. But you have to make sure that if you want to do something with the data and with the response, that has to be within this .then function, because that's when it resolves. Up until that bit, you don't know whether you've got data or not, because you don't know how long it's going to take for this promise to resolve. You can set a timeout, so it could be up to 30 seconds. You could, as an example, up to 30 seconds. It could error out. You can never get a response. There's a lot of things that go wrong outside of the program, and you have to account for real world problems. There is some nicer syntax that you can use with TypeScript. You can write it like this. If you define the function to be async, you can use the await keyword just after data. Data equals await http.get, whatever. And that just means that when the program runs, whatever the promise returns, just put it into data. And then you can wrap the entire thing in a try catch to make sure that if it errors out, you can do your error handling that way. I'm conscious of the time. This is only meant to be 10 minutes. So that's just a very brief overview of what asynchronous things can do, how you'd actually use that in programming, and just some common pitfalls. The fact that you have to think outside the box. I hate that phrase. You have to think of what can go wrong in like physical hardware. What happens if you don't have an internet connection? what happens if the response is longer than you anticipated? You've got to do some more rigorous error handling and sort of null checks. But it can be a very powerful tool, especially when dealing with front-end users. And that's all I had.